Guys, and welcome to a new video. In this video we are going to solve some exercise on circuits. So the first system we are going to analyze is the following. We have this power supply V, and then we have two resistors. Okay, so the first resistor, let's call it R1, and the second one is R2. Okay, so as you can see, the two resistors we have a series of two resistors. So we have R1 and R2, and we know that R1 is 100 ohm and R2 is 100 ohm as well. Okay, and we know that V, so the power supply, is 10 volt. Okay, so we have to find the current flowing through this circuit, and we will have also to find the voltage across these two resistors, so the voltage between this point and this point. Okay, so the idea here is that the two resistors are we have a series of resistors, so since the two resistors are in series, we have to sum the values of these two resistors in order to obtain basically an equivalent resistor. So we know that R1 plus R2, this result gives us the total or the equivalent resistor. Let's call it R equivalent, and this is given by 200, is equivalent to 200 ohm. Okay, so we know from the ohm law the voltage across the two resistors is given, so we can call this voltage V, is given by the product between the current and the total resistance here between these 2 points, which is R equivalent, as we said. So this means that from here the current of the circuit is given by the voltage across between these 2 points over the equivalent resistance. And so that means that basically we have to find the voltage between these 2 points, but we know from the Kirchhoff's law that the power supply has to be equivalent to the voltage between across the two resistors, so that means that V is 10 volt as well. Okay, so this basically means that we have everything to calculate the current. So we know that the current is given by this ratio, so it is 10 volt over 200 ohm. So this is basically 0.05 ampere. Okay, so this is the current of this system basically. Okay, so here we also calculated the voltage across the two resistors, and if we want to know the voltage across one single resistor, well, here we basically have to apply again the law, the Ohm law. So if we want, for example, V1, so the voltage across the first resistor here, we basically have to multiply I and R1. So here we would get 0.05 ampere times the first resistance, so 100 ohm, and this gives us 5 volt. So this is the voltage across the first resistance R1, and since the two resistors here are the same, that means that the voltage across the second resistor will be the same, and as we expected, the sum of the first voltage across the first resistor and the voltage across the second resistor is 10 volt, which is the voltage across the equivalent resistance. So, okay, so we are happy with this result. In the second exercise we have another circuit, and in this circuit we have again the power supply V. And then we have two resistors. This time the two resistors are in parallel, so we have two parallel resistors. Let's call them again R1 and R2. And we know that R1 is 10 ohm and R2 is 30 ohm. Okay, and we know also that the power supply is 12 volt, and we have to find the current flowing in the circuit, so the total current I, and we have also to find the current flowing through the two resistors. So I call them I1 and I2, and this will be I2, and we know that I is this one. Okay, and we have also to find the voltage across the two resistors, so again we can call them V1 and V2. Okay, so again here it is convenient to find the equivalent resistor of the system. So in this case we have two resistors which are in parallel. So we know from the theory that the sum 1 over R1 plus 1 over R2 will be 1 over the equivalent resistance. So previously, as the resistors were in series, we had just to multiply the two resistors, but now since the two resistors are in parallel we have to consider this relation. Okay, so we have to find the equivalent resistance here, so that means that R equivalent, so if you change here this, if you work on this equation, you can find that R equivalent is given by R1 times R2 over the sum R1 plus R2. Okay, so in this case we would get R1 was 10 times R2, which is 30 over 10 plus 30 ohm, 7.5 ohm, and this is the equivalent resistance, the equivalent resistor. So that means that this time the current, again we can find it from again the ohm law. So the voltage across the two resistors is again is 12 volt, so the same as the power supply, and we know that this is given by the product I times R, equivalent from the ohm law. So that means that from here I, so the current is given by the power supply over the equivalent resistance. So this time if we would get 12 volt over 7.5 ohm, and this if you put in these values in the calculator you will get 1.6 ampere. So this is the let's say the total current flowing through this system. We have now to find the values of the voltage, the voltages across the two resistors, so the voltage across this point, between this point and this point, and the voltage between this point and this point. And we have also to find the current here I2 and the current here I1. We know that the voltage across the two resistors, so the voltage between this point and this point is the same and is equivalent to the power supply, and this comes from the Kirchhoff's voltage law, because again, as we know, V, so the power supply is equivalent to V1 and equivalent to V2 because of the Kirchhoff's voltage law, and this means that all these voltages are 12 volt. Okay, so this is the values of the voltages across the two resistors, and now since we are interested in the current flowing through the two resistors, we again can apply Ohm law, because we know that, for example, V1 is given by E1 times R1, so that means that the voltage from between this point and this point can be calculated considering this current and this resistor. That means that I1, so the first current, is V1 over R1, so that means that this is 12 volt over R1, which was 10 ohm, so this will be 1.2 ampere. So this is the first current flowing through the first resistor. The second current can be so I2 can be calculated in the same way, or we can also find I1 knowing that I, so the current flowing through the system, is given by the sum I1 plus I2, and this law is the Kirchhoff's current law. So we know I, we know I1, and so from here we know that I2 will be I minus I1. So as we said, 1.6 ampere minus 1.2 ampere, so this will be 0.2